Hello everybody, thank you for watching. In this video 2.11, we're going to look at half-life example problems. So the first thing we're going to learn in this video is to just kind of understand how long it takes for unstable nuclei to decay. In our previous video we talked about what half-life was, and now we're just going to do a couple example problems regarding half-life. So we have our first example. So the first example says, if you start with a 120 gram sample of radium, how much will be left after 44 days? So this right here in this box tells you the half-life of radium. So this is the time it takes for half of the sample to decay. So it's going to take 11 days for a 120 gram sample of radium to decay in half. So half of 120 is 60 grams, and that's going to take 11 days. So then it's going to take another 11 days for it to decay again into 30 grams. We want to know how much will be left after 44 days. So if you do a little bit of math, if we have 44 days divided by 11 days for each half-life, we're going to undergo 4 half-lives in this equation. So when it gets decayed the first time using 11 days, that's our first half-life. When it undergoes another decay, that is our second half-life. We're going to keep doing this until we pass 4 half-lives. So right now we have 30 grams of that sample. So in another 11 days, it is going to be cut in half, and we're going to be left with 15 grams, right? Lastly, another 11 days is going to go by, and this is our last half-life. We are going to have 7.5 grams left. So this is your answer. How much will be left after 44 days? The answer is we're going to be left with 7.5 grams of radium. So if you look at this right here, the percentage left. So in the last video we talked about percentages and how much decays every time you undergo a half-life. So the first thing is, whenever you start a half-life, you already have 100% of that sample. Once the first half-life goes by, you end up decaying half of it, so you're left with 50%. After another half-life, you are left with 25% of that sample, and then this number just keeps getting cut in half, and that's how much you have left of your original sample. The percentage that gets to the other sample, the amount that's being decayed, is just whatever that difference is. Right? So after 4 half-lives, we're only going to have 6.25% left of our radium that we originally started with. Here's our second example problem. So we have an 80-gram sample of hydrogen. This is tritium. And we are leaving 2.5 grams of tritium, and we want to figure out how long this will take. So we originally are starting with 80 grams of this sample. The half-life for this is 12.3 years, right? So how long will this take if we leave 2.5 grams? So we're just going to keep doing half-lives until we are left with 2.5 grams. So half of 80, when 12.3 years go by, we're going to be left with 40 grams. And then another half-life is going to go by. We're going to be left with 20 grams, and that's going to take another 12.3 years. Another 12.3 years, we're going to be left with 10 grams. And then another half-life, we're going to be left with 5 grams. And then another 12.3 years, we're going to have 2.5 grams. So how long will this take? If you count how many half-lives you underwent, we went through 1 here, 2, 3, 4, 5. So we underwent 5 half-lives, and each half-life is 12.3 years. Times 5 half-lives, this is going to take a total of 61.5 years for us to decay and be left with 2.5 grams of our original tritium. If you take a look at our percentages, it's just asking you how many half-lives will leave us with 3.1% of hydrogen. We know when we start, we have 100%. This is 50%. This is 25%, 12.5%, 6.25%, and then lastly 3.1%. So how many half-lives went by? Total of 5. T1 half. Last example problem. So you start with 200 grams of thallium-207. After 20 minutes, there was only 12.5 grams of thallium left. So what is the half-life of the decay process? So this question is asking you to calculate what our half-life is. So how long does it take for half of the sample to decay? We know that this total amount of time that went by was 20 minutes. So whatever this is, it's going to equal 20 minutes. So let's start by cutting this sample in half. So after an X amount of time, we know that we have 100 grams of the sample left. Another X amount of time, 50 grams, and then 25 grams. And then lastly, we have 12.5 grams left. And that's how much is given in the problem. So you want to figure out how long this took. So we know all this equals 20 minutes. So you can count how many half-lives you underwent. So 1, 2, 3, 4. So if you take 20 minutes and divide that by our total of 4 half-lives, each half-life is going to be 5 minutes. So our T equals 1/2 is going to be 5 minutes. I hope this video helps. Thank you for watching.